Michio Kaku's latest discovery has once again sent shockwaves through the scientific community. And if you've ever wondered what lies at the very fabric of reality, this is the moment you've been waiting for. Imagine a world where the rules of physics as we know them are just the tip of the iceberg, where the universe is not just a vast expanse of stars and galaxies, but a symphony of vibrating strings, each note playing a role in the grand cosmic orchestra. This is not science fiction. This is the cutting edge of theoretical physics, and Michio Kaku is at the forefront of this revolutionary exploration. His latest discovery delves deeper into the mysteries of the universe, challenging our understanding of reality itself. It's a journey that takes us beyond the visible, beyond the tangible, and into a realm where the very building blocks of existence are redefined. To understand the significance of Kaku's latest breakthrough, we must first grapple with the fundamental questions that have haunted scientists for centuries. What is the universe made of? What are the fundamental constituents that make up everything we see, touch, and experience? For decades, physicists have been searching for a theory that can explain the physical properties of nature at the smallest scales. A theory that can unify the forces of the universe into a single, coherent framework. This quest has led to the development of quantum mechanics, a field that explores the behavior of particles at the subatomic level. But quantum mechanics, while incredibly successful, is not the final answer. It leaves many questions unanswered, and that's where Michio Kaku's work comes in. Kaku's latest discovery is rooted in string theory, a framework that has been described as the most promising candidate for a theory of everything. String theory proposes that the fundamental building blocks of the universe are not point-like particles, as traditionally thought, but tiny vibrating strings. These strings, which are unimaginably small, vibrate at different frequencies, and each vibration corresponds to a different particle. In this way, the diversity of particles in the universe, electrons, quarks, photons, and more, can be explained as different notes played by these strings. It's a breathtakingly elegant idea, one that suggests the universe is not just a collection of random particles, but a harmonious symphony of vibrations. But string theory doesn't stop there. It also introduces the concept of extra dimensions, dimensions beyond the three spatial dimensions we are familiar with. According to string theory, these extra dimensions are curled up and hidden from our everyday perception, but they play a crucial role in the behavior of the strings. This idea is mind-bending, to say the least, and it opens up the possibility of a multiverse, a vast collection of parallel universes, each with its own set of physical laws. Kaku's latest work takes this idea even further, exploring the implications of these extra dimensions and how they might influence the fundamental forces of nature. One of the most exciting aspects of Kaku's discovery is its potential to explain some of the greatest mysteries in physics. Take dark matter, for example. Dark matter is a mysterious substance that makes up about 27% of the universe, yet it doesn't interact with light or any other form of electromagnetic radiation, making it invisible to our telescopes. Despite its elusive nature, dark matter's gravitational effects are undeniable, and it plays a crucial role in the formation and evolution of galaxies. But what is dark matter made of? This is one of the biggest unanswered questions in modern physics, and Kaku's work suggests that string theory might hold the key. According to his latest findings, dark matter could be composed of particles known as WIMPs, weakly interacting massive particles that arise from the vibrations of strings in these extra dimensions. If this is true, it would be a monumental breakthrough, one that could finally shed light on the nature of this enigmatic substance. But the implications of Kaku's discovery go even deeper. String theory also offers a potential explanation for the mystery of quantum entanglement, a phenomenon that Albert Einstein famously referred to as spooky action at a distance. Quantum entanglement occurs when two particles become linked in such a way that the state of one particle instantly influences the state of the other, no matter how far apart they are. This phenomenon defies our classical understanding of space and time, and it has puzzled physicists for decades. Kaku's work suggests that the extra dimensions proposed by string theory could provide a framework for understanding how entanglement works, offering a glimpse into the hidden connections that bind the universe together. Tridimensions and tiny strings proposed by the theory are far too small to be observed directly with current technology, and this has led some scientists to question whether string theory is truly a scientific theory at all. After all, a theory that cannot be tested or falsified is by definition not scientific. Kaku acknowledges these challenges, but he remains optimistic. He believes that as technology advances, we will eventually find ways to test the predictions of string theory, either through high-energy particle collisions or through observations of the cosmos. And when that day comes, it could revolutionize our understanding of the universe. Kaku's latest discovery also touches on one of the most profound questions in physics: the nature of time. Time is something we all experience, yet it remains one of the most elusive concepts in science. According to Einstein's theory of relativity, time is not absolute, but relative, flowing at different rates depending on the observer's motion and gravitational field. But string theory takes this idea even further, suggesting that time itself might be an emergent property of the interactions between strings. In other words, time might not be a fundamental aspect of the universe, but something that arises from the underlying structure of reality. This is a radical idea, one that challenges our most basic intuitions about the nature of existence. Of course, string theory is not without its critics. One of the main challenges facing the theory is its lack of experimental verification. As we delve deeper into Kaku's latest work, it's impossible not to feel a sense of awe and wonder. The universe, as described by string theory, is not just a cold, lifeless expanse of matter and energy, but a vibrant, dynamic entity filled with hidden dimensions and vibrating strings. It's a universe that is far more complex and mysterious than we ever imagined. And yet, at the same time, it's a universe that is governed by elegant, mathematical principles. Kaku's ability to convey these ideas in a way that is accessible and engaging is one of the reasons why he is such a beloved figure in the world of science. He has a unique gift for making the most abstract and esoteric concepts seem tangible and relatable, and his latest discovery is no exception. But perhaps the most exciting aspect of Kaku's work is the sense of possibility it inspires. String theory is still in its infancy, and there is so much we don't yet understand. But every new discovery, every new insight, brings us closer to unraveling the mysteries of the universe. Kaku's latest breakthrough is a reminder that science is not just about answering questions, but about asking them, about pushing the boundaries of what we know and exploring the unknown. It's a reminder that the universe is full of surprises, and that the journey of discovery is far from over. As we reflect on Michio Kaku's latest discovery, it's impossible not to feel a sense of excitement and anticipation. The universe, as we know it, is just the beginning. There is so much more to explore, so many mysteries to unravel, and so many questions to answer. Kaku's work is a testament to the power of human curiosity and the relentless pursuit of knowledge. It's a reminder that the universe is not just a place to live, but a puzzle to be solved, a symphony to be understood, and a story to be told. And as we continue to explore the mysteries of the cosmos, we can only imagine what wonders await us. The journey is far from over, and the best is yet to come. The beauty of Michio Kaku's latest discovery lies not just in the answers it provides, but in the questions it raises. Every breakthrough in science opens new doors, and Kaku's work is no exception. It challenges us to rethink our understanding of reality, to question the very nature of existence, and to imagine a universe that is far more intricate and interconnected than we ever thought possible. This is the essence of scientific exploration, the relentless pursuit of truth, no matter how elusive or complex it may be. And Kaku's latest discovery is a shining example of this pursuit, a beacon of hope for those who dare to dream of a deeper understanding of the cosmos. One of the most profound implications of Kaku's work is the idea that the universe is not a static, unchanging entity, but a dynamic, evolving system. The vibrations of strings, the interplay of dimensions, and the emergence of particles all suggest a universe that is in a constant state of flux. This idea resonates deeply with our own experiences as human beings. We, too, are constantly changing, evolving, and adapting to the world around us. In this sense, Kaku's discovery is not just a scientific breakthrough, but a philosophical one as well. It reminds us that we are not separate from the universe, but an integral part of it, connected to the cosmos in ways we are only beginning to understand. Kaku's work also challenges us to confront the limitations of our own perception. The extra dimensions proposed by string theory are hidden from our view, curled up and compactified in ways that make them invisible to our senses, yet they play a crucial role in shaping the universe as we know it. This raises an intriguing question. What else are we missing? What other aspects of reality lie beyond our perception, waiting to be discovered? Kaku's discovery is a call to humility, a reminder that our understanding of the universe is still in its infancy and that there is so much more to learn. At the same time, Kaku's work is a testament to the power of human imagination. The idea that the universe could be composed of tiny, vibrating strings is not something that can be observed directly. It is a product of the human mind, a leap of imagination that has led to one of the most profound theories in the history of science. This is the essence of theoretical physics, the ability to envision a reality that lies beyond our senses and to use mathematics as a tool to explore that reality. Kaku's latest discovery is a celebration of this creativity, a reminder that science is not just about observation and experimentation, but about imagination and intuition. But perhaps the most inspiring aspect of Kaku's work is its potential to unite the disparate fields of science. String theory is not just a theory of physics, it is a theory of everything, a framework that seeks to unify the fundamental forces of nature into a single, coherent picture. This is no small feat. For centuries, scientists have been trying to reconcile the laws of quantum mechanics, which govern the behavior of particles at the smallest scales, with the laws of general relativity, which describe the behavior of gravity on cosmic scales. These two theories are incredibly successful in their own domains, but they are fundamentally incompatible. String theory offers a way to bridge this gap, to create a unified theory that can explain the universe at all scales. Kaku's latest discovery brings us one step closer to this goal, offering new insights into how these forces might be connected. Of course, the road to a unified theory is not without its challenges. String theory is still a work in progress, and there are many unanswered questions. For example, how do the extra dimensions proposed by string theory manifest themselves in the observable universe? What is the nature of the strings themselves, and how do they interact with one another? These are complex questions, and they will require years, if not decades, of research to answer. But Kaku's work gives us hope that these questions are not insurmountable, that with time and effort, we can unravel the mysteries of the universe. Kaku's latest discovery also has profound implications for the future of technology. If string theory is correct, it could open up entirely new possibilities for energy, communication, and even space travel. For example, the existence of extra dimensions could provide new ways to manipulate gravity, potentially leading to breakthroughs in propulsion systems that could take us to the stars. Similarly, the vibrations of strings could be harnessed to create new forms of energy, revolutionizing the way we power our world. These ideas may sound like science fiction, but they are grounded in the principles of string theory. And Kaku's work is helping to bring them closer to reality. But beyond the practical applications, Kaku's discovery has a deeper significance. It reminds us of the power of science to inspire and uplift, to connect us to something greater than ourselves. In a world that often feels divided and fragmented, Kaku's work is a reminder of the unity and interconnectedness of all things. It is a call to look beyond our differences and to see the underlying harmony that binds the universe together. This is the true beauty of science, not just the answers it provides, but the sense of wonder and awe it inspires. As we reflect on Michio Kaku's latest discovery, it's impossible not to feel a sense of gratitude for the scientists who dedicate their lives to exploring the mysteries of the universe. Their work is not just about advancing human knowledge, it is about expanding our horizons, challenging our assumptions, and inspiring us to dream of a better future. Kaku's latest breakthrough is a testament to the power of curiosity, creativity, and perseverance. It is a reminder that the universe is full of surprises, and that the journey of discovery is far from over. So what does the future hold? If Kaku's work is any indication, the possibilities are endless. As we continue to explore the mysteries of string theory, we may uncover new dimensions, new particles, and new forces that will revolutionize our understanding of the universe. We may find answers to some of the most profound questions in science, from the nature of dark matter to the origins of the cosmos. And along the way, we may discover new technologies, new ways of thinking, and new ways of being that will transform our world. But perhaps the most exciting prospect is the idea that we are just beginning to scratch the surface of what is possible. The universe, as described by string theory, is a vast, intricate, and endlessly fascinating place, full of mysteries waiting to be uncovered. Kaku's latest discovery is a reminder that we are part of this grand cosmic story, that we have the power to explore, to learn, and to grow. It is a call to embrace the unknown, to push the boundaries of what we know, and to dream of a future that is brighter, bolder, and more beautiful than we can imagine. In the end, Michio Kaku's latest discovery is not just a scientific breakthrough, it is a celebration of the human spirit. It is a reminder that we are capable of greatness, that we have the power to unlock the secrets of the universe and to shape our own destiny. It is a call to curiosity, to creativity, and to courage. And it is a testament to the enduring power of science to inspire, to uplift, and to transform. So as we stand on the brink of a new era of discovery, let us embrace the journey with open hearts and open minds. The universe is waiting, and the best is yet to come.